Welcome to Spring LIB.
Okay, so we want to know how much we need to move a mirror and a Michelson interferometer to have 650 fringes of 589 nanometers light pass through a reference line. So let's go ahead and get the givens down first. And then we can say n is 650 fringes. So from the book, it basically says for every distance you move the distance d that you move the mirror, you get twice the difference in optical path length. So we can say the distance we move the mirror d is 2 times x, where x is the optical path length difference. And they kind of talk about this in terms of lambda over 2 and lambda. And so we know that for every, as kind of from the text, we know that every time you move, every time you move by lambda over 2, you go, well, I guess we know from this formula, every time, like, let's say, sorry, let me just pause and collect my thoughts. Okay, so I think I misspoke when I wrote that down. So let's just kind of use a diagram to help us. So here's the light, here's a beam splitter, and it's going here, here, here's the mirror, and then you kind of look at the interference here. So if you move this mirror, let's say by some distance, x, then if we are concerned with the optical path length difference d between the two paths, it's just double what this distance is, because this has to move over, the photon has to move over this distance twice. And so okay, so that's what the meaning of d is equal to 2x is. And so now let's consider if we see what it means that we've seen 650 fringes. Well, that means that we've seen, so for a fringe to appear, that means that d has to be, the optical path length difference has to be an integer multiple of pi. So let's just say lambda. So equal to m times lambda. And so if it's 1 lambda, then they're 1 lambda apart. If it's 2 lambda, it's 2 lambda apart, et cetera, et cetera. And so if we know that it's 650 fringes, we can say m is equal to 650. And then from this formula, we can set it equal to 2x. And then we can say that x is m lambda over 2. And I'm just going to double check that that's what they wanted. So let's go ahead and calculate that. So I wonder if I can do this one in my head. Oh no, 589. So 650 times 589 divided by 2 times 10 to the minus 9. So then that's 1, 2, 3, 4, 1.9 times 10 to the minus 4. 1, 2, 3, 4, yeah. And let me get the third sig fig. 1.91 times 10 to the minus 4.